The anatomy of a modern warship for centuries. Warships have ruled the oceans, serving as symbols of power, deterrence, and strategic dominance. From the wooden sailing ships of the age of exploration to today's highly sophisticated naval vessels, warships have evolved into technological marvels designed for combat, defense, and survival in some of the harshest conditions on Earth. Modern warships are not just floating platforms armed with weapons. They are engineered for stealth, agility, and overwhelming firepower. Every detail of their exterior design, armor protection, and onboard weaponry is optimized to ensure battlefield superiority. But what exactly makes these ships so formidable? Let's start by dissecting their exterior components. The hull, the backbone of the warship. The hull is the main structure of a warship, forming its outer shell and defining its hydrodynamics, speed, and defensive capabilities. Unlike commercial ships, warships are designed with reinforced hulls to withstand missile impacts, high-speed maneuvers, and even underwater explosions. Stealth hull design. Modern warships feature angled surfaces and radar-absorbing materials to minimize their radar cross-section. The USS Zumwalt, a futuristic destroyer, uses a sleek, angular hull to deflect radar waves, making it appear as small as a fishing boat on enemy radar. Double hull protection. Submarines and some surface warships use double hull structures to provide an extra layer of defense against torpedo strikes. The inner hull houses vital compartments, while the outer hull absorbs damage. Wave-piercing bow. High-speed warships, such as the Littoral Combat Ship, LCS, use a sharp, wave-piercing bow to cut through rough seas with minimal resistance, ensuring higher speed and fuel efficiency. Superstructure. The brain of the warship. The superstructure is the part of the ship above the main deck, housing the bridge, radar systems, and advanced sensors. It plays a crucial role in command and control, communication, and navigation. Bridge and Combat Information Center, CIC. The bridge is where officers navigate the ship, while the CIC is the nerve center, where battle strategies are executed. These areas are reinforced to withstand explosive shock waves and EMP attacks. Radar and sensor domes. The towering radar domes on a warship house. Active Electronically Scanned Array, AESA, radar systems, capable of tracking hundreds of targets simultaneously. The Aegis combat system, used on many U.S. Navy ships, allows real-time coordination of missile strikes and air defense. Electronic warfare suites. Warships now integrate electronic warfare, EW systems, to jam enemy radar, disrupt missile guidance systems, and counter cyber attacks, making them much harder to target. Armor and defensive layers. A warship's defensive capabilities are just as important as its offensive firepower. Advanced naval vessels are designed to survive direct missile hits, underwater mines, and even nuclear shock waves. Ballistic protection. Some warships, like aircraft carriers, feature Kevlar-reinforced armor plating to absorb shrapnel and explosive blasts. Torpedo defense systems. Modern destroyers deploy decoy torpedoes and underwater countermeasures to disrupt incoming threats. The Russian Udaloy-class destroyers, for example, use the Packet NK system to launch torpedoes that intercept enemy torpedoes before impact. NBC, nuclear, biological, chemical, shielding. In the event of nuclear fallout or biological attacks, warships are sealed with overpressure systems and decontamination stations, ensuring crew survival in extreme conditions. Deck design, where offense meets defense. The deck of a warship is not just a walking surface. It is a platform for launching missiles, deploying aircraft, and executing naval warfare strategies. Vertical launch systems, VLS. Many warships are equipped with VLS cells, allowing them to fire multiple missiles in rapid succession, including anti-air, anti-ship, and cruise missiles. The Ticonderoga-class cruisers of the U.S. Navy can launch over 120 missiles in minutes. helipads, and hangars. Many warships carry attack helicopters and drones to extend their surveillance and attack capabilities. The MH-60R Seahawk helicopter, for instance, is used for anti-submarine warfare, search and rescue, and reconnaissance missions. Gun turrets and artillery systems. While missiles dominate modern warfare, naval guns like the Mk-45 127mm cannon still provide shore bombardment and close-range defense. Some newer warships are even testing electromagnetic railguns for long-range precision strikes. 5. Stealth features. The invisible warships. One of the most significant advancements in naval warfare is stealth technology. Modern warships are built to be harder to detect, track, and target by enemy forces. Radar-absorbing paint. Special coatings reduce the ship's radar signature by absorbing electromagnetic waves. The Chinese Type 055 destroyer uses stealth coatings to blend into the ocean environment. Heat. Signature reduction. Exhaust ports are designed to cool and diffuse heat emissions, making it harder for infrared-guided missiles to detect the ship. The French Lafayette-class frigate was one of the first to implement this technology. Acoustic dampening. Submarines and some surface ships use anechoic tiles to absorb sonar pings, reducing underwater detectability. Propulsion systems. Speed and endurance at CA warship's propulsion system dictates its speed, maneuverability, and operational range. The most advanced warships use hybrid propulsion technologies for greater efficiency. Gas turbine engines. Many modern destroyers use high-powered gas turbines for rapid acceleration, reaching speeds of over 30 knots, 56 km/h. Nuclear reactors. Aircraft carriers and submarines use nuclear reactors, providing unlimited range and endurance, allowing them to remain at sea for decades without refueling. The Gerald R. Ford-class aircraft carriers are powered by 2 nuclear reactors, generating enough electricity to power a small city. Hybrid electric systems. Some warships, like the Royal Navy's Type 45 destroyers, combine diesel-electric and gas turbine engines for greater fuel efficiency and reduced emissions. Inside the floating fortress warships are designed to be floating fortresses, built to withstand the most extreme combat conditions while housing cutting-edge technology. Their hulls absorb damage, their radars track threats from hundreds of kilometers away, and their weapons unleash destruction with unparalleled precision. But the true power of a warship lies in its arsenal of weaponry, from hypersonic missiles to laser defense systems. In the next section, we'll dive deep into the firepower of modern warships, exploring missiles, torpedoes, railguns, and electronic warfare systems. These weapons don't just protect the ship, they define the future of naval dominance. The arsenal of war. A look at warship. Weaponry warships are not just floating fortresses. They are mobile weapons platforms designed to unleash devastating firepower across land, sea, and air. From long-range cruise missiles to cutting-edge railguns, the weapon systems of modern warships dictate naval supremacy. In this section, we break down the primary offensive and defensive weapons that make warships the ultimate machines of destruction. Missile systems. The warship's first line of attack missiles are the most powerful weapons in a modern warship's arsenal, capable of striking enemy targets from hundreds or even thousands of kilometers away. They can be divided into several key categories. Anti-ship missiles, ASMs. Designed to sink enemy warships, these missiles use radar, infrared guidance, and sea-skimming capabilities to evade defenses. The Russian P-800 Onyx and the U.S. Harpoon missile are prime examples of ship-killing weaponry. Land attack cruise missiles, LACMs. Used for striking enemy infrastructure and military bases, these missiles have precision guidance systems and long-range capabilities. The Tomahawk missile, used by the U.S. Navy, has a range of 1,600 kilometers and can be programmed for multiple targets mid-flight. Ballistic Missile Defense, BMD systems. Some warships, like the Arleigh Burke-class destroyers, are equipped with the Aegis Ballistic Missile Defense System, capable of intercepting and destroying incoming ballistic missiles. The SM-6 interceptor is designed to shoot down threats before they reach their targets. Hypersonic missiles. The latest generation of warship missiles, such as Russia's 3M-22 Zircon and China's DF-17, travel at speeds exceeding Mach 5, making them nearly impossible to intercept. These weapons represent the future of naval warfare. Close-in weapon systems, CIWS, the last line of defense. While long-range missiles dominate modern naval warfare, warships still need point defense systems to destroy threats that evade primary defenses. The Gatling gun, CIWS, the Phalanx. CIWS, used by the U.S. Navy, features a 20mm 6-barrel Gatling gun that fires 4,500 rounds per minute, creating a wall of bullets to intercept incoming missiles. Laser defense systems. The U.S. Navy is testing the LAWS, laser weapon system, capable of burning through enemy drones and small boats with pinpoint accuracy. Future laser systems may neutralize hypersonic missiles at the speed of light. Missile-based CIWS. Systems like CRAM combine close-range missiles with advanced targeting to shoot down enemy threats before impact. 3. Torpedo systems. The underwater killers. Torpedoes remain a silent but deadly weapon in naval combat, capable of sinking even the largest warships. Heavyweight torpedoes. These torpedoes, such as the Mark 48 AD Cap, are designed to sink submarines and surface ships with explosive warheads and advanced homing systems. Supercavitating torpedoes. The Russian VA-111 Shkval is a supercavitating torpedo that travels at over 370 km/h underwater, using a gas bubble to reduce water resistance. Anti-torpedo systems. Warships deploy torpedo decoys and countermeasure torpedoes to intercept enemy attacks. The U.S. Navy's Surface Ship Torpedo Defense (SSTD) system is designed to detect and neutralize incoming threats. Railguns. The future of naval firepower electromagnetic railguns are game-changers in naval warfare. Unlike conventional cannons that use gunpowder, railguns use electromagnetic energy to launch projectiles at hypersonic speeds. High velocity and range. Railguns can fire projectiles at speeds of over 7,200 km/h, covering distances of more than 200 kilometers. Penetrating power. Unlike missiles, railgun shells do not require explosives, relying on pure kinetic energy to destroy targets. Challenges. While promising, railguns require massive amounts of energy, making their deployment on warships technologically challenging. Electronic warfare, EW. The invisible battlefield. Naval combat is not just about missiles and guns. Electronic warfare is becoming one of the most critical aspects of modern naval strategy. Radar jamming. Warships use powerful electronic warfare suites to jam enemy radars and disrupt missile targeting systems. The U.S. ANSLQ-32 EW system can detect and counter incoming threats before they reach the ship. Cyber warfare. Some warships are now equipped with cybersecurity teams to counter hacking attempts on naval systems. Cyber attacks can disrupt communication, disable weapons, and even reroute missiles. Decoy systems. Warships deploy radar-reflecting decoys and infrared flares to mislead enemy sensors, diverting missiles away from the real target. 6. Unmanned systems. The rise of AI-powered combat. Modern warships are beginning to integrate autonomous and AI-driven systems for combat and defense. Unmanned surface vessels, USVs. The U.S. Navy is testing drone warships like Sea Hunter, capable of hunting enemy submarines autonomously for weeks without human intervention. Combat drones. Many warships now carry armed drones for surveillance, reconnaissance, and missile strikes. The MQ-8C Fire Scout drone can operate from warships, providing real-time intelligence, AI-enhanced targeting. Some navies are integrating AI-assisted fire control systems to improve accuracy and reduce reaction time in combat situations. Naval warfare in the 21st century. Warships are no longer just floating artillery platforms. They are high-tech command centers. electronic warfare, hubs, and missile fortresses. Their ability to strike from a distance, defend against any threat, and operate autonomously makes them a vital part of global military strategy. But the true power of warships lies not just in their weaponry, but in their role as a deterrent. A single state-of-the-art destroyer or aircraft carrier can control vast ocean territories, protect vital trade routes, and serve as a symbol of military dominance. In the final section, we will explore how naval warfare is evolving, looking at future warship designs, next-generation weapons, and the impact of AI and space-based defense systems on modern fleets. The future of warships. Next-generation naval power. As technology evolves, so does naval warfare. The warships of tomorrow will be faster, stealthier, more powerful, and more autonomous than ever before. Nations around the world are racing to develop next-generation fleets equipped with AI-driven combat systems, hypersonic missiles, energy weapons, and even space-based defenses. In this final section, we explore the future of warships and how they will redefine naval dominance. Stealth technology. The rise of invisible warships. Stealth is no longer exclusive to aircraft. Navies are investing heavily in stealth warships to evade enemy radars and enhance survivability. Radar-absorbing materials. Modern stealth ships like the U.S. Zumwalt-class destroyer and the Chinese Type 055 destroyer use advanced coatings that absorb and deflect radar waves, making them nearly invisible on enemy scopes. Angular hull design. Unlike traditional warships with sharp angles, stealth ships feature sloped hulls that scatter radar signals instead of reflecting them back to the enemy. Reduced thermal and acoustic signatures. Future warships will incorporate heat-reducing materials and quiet propulsion systems to evade infrared detection and submarine tracking. 2. Hypersonic weapons. The new era of naval warfare. The development of hypersonic weapons, capable of traveling at speeds over Mach 5, 6,100 km/h, is changing the way warships engage in combat. Hypersonic cruise missiles. Russia's 3M-22 Zircon and China's YJ-21 can strike enemy ships and land targets within minutes, making traditional missile defenses nearly obsolete. AI-powered targeting. Hypersonic weapons will require real-time, AI-assisted targeting to track and neutralize threats traveling at unprecedented speeds. Countermeasures. Future warships will need advanced space-based tracking systems, laser weapons, and electromagnetic shields to defend against hypersonic attacks. Directed energy weapons, DEWs, lasers and railguns. The future of naval firepower lies in directed energy weapons, which provide instantaneous, unlimited ammunition and extreme precision. Laser weapon systems. The U.S. Navy is testing high-powered laser cannons capable of melting enemy drones, missiles, and small boats at the speed of light. Unlike traditional weapons, lasers require no ammunition, making them a cost-effective solution for continuous defense. Electromagnetic railguns. Warships of the future will likely replace traditional naval guns with railguns capable of firing hypervelocity projectiles at over 7,200 km/h, striking targets over 200 km away without explosives. Microwave weapons. High-power microwave systems could disable enemy electronics, communication systems, and even missile guidance systems, rendering them useless. Artificial intelligence and automation. The autonomous Navy AI is becoming a critical component of future warships, enabling autonomous navigation, combat decision-making, and rapid threat assessment. AI-enhanced combat systems. Future warships will integrate AI-driven targeting and fire control, reducing human reaction time and improving accuracy in high-stress situations. Unmanned warships. The U.S. Sea Hunter and China's Jerry USV are examples of autonomous warships that can operate without a crew, conduct surveillance, and even engage in combat using AI-driven decision-making. Swarm warfare. The concept of drone swarms, hundreds of AI-controlled drones attacking in unison, could revolutionize naval combat by overwhelming enemy defenses. Space-based naval defense. The next battlefield navies are beginning to look beyond Earth's surface, exploring space-based assets for surveillance, communication, and missile defense. Satellite-guided warfare. Modern warships rely heavily on GPS satellites for navigation, targeting, and missile guidance. Future fleets may use low-orbit satellite constellations to enhance precision strikes. Orbital missile defense. The U.S. Space Force and Navy are working on satellite-based laser systems and kinetic kill vehicles to intercept enemy missiles before they reach their targets. Hypersonic glide vehicles. Nations are developing space-launched hypersonic weapons, capable of attacking targets from the upper atmosphere, bypassing traditional missile defenses. The future of aircraft carriers. Supercarriers and drone carriers. Aircraft carriers remain the backbone of naval power, but the next generation of carriers will feature fully autonomous drone squadrons, electromagnetic catapults, and even submersible capabilities. Drone-based carriers. Future carriers, like the proposed USS Lightning, may rely primarily on unmanned combat drones rather than piloted aircraft. These carriers will be smaller, faster, and harder to detect. Electromagnetic aircraft launch systems, EMALS. Instead of traditional steam catapults, next-gen carriers will use EMALS to launch fighter jets with greater efficiency, reducing stress on aircraft and increasing launch speeds. Nuclear-powered carriers. The next fleet of supercarriers, like the Gerald R. Ford class, features nuclear reactors capable of powering advanced weapons, including railguns and laser defenses. 7. Climate change and the future of naval warfare. Rising sea levels, shifting geopolitical tensions, and new resource disputes in the Arctic and South China Sea are pushing navies to adapt to a changing world. Arctic warfare. Melting ice caps are opening new sea routes and potential conflict zones. Nations are deploying icebreaker warships and Arctic-capable fleets to secure strategic dominance. Green warships. Future naval fleets may transition to hydrogen fuel cells, biofuels, and even fully electric propulsion systems to reduce environmental impact. Underwater drones. Climate change is making underwater warfare more crucial, leading to the development of autonomous submarine drones for surveillance and combat. The future of naval power. A new era begins. Warships are no longer just vessels of destruction. They are high-tech platforms of dominance, diplomacy, and deterrence. The race for hypersonic supremacy, AI-driven warfare, and space-based defense will define the next century of naval combat. As technology advances, traditional naval strategies will become obsolete. Future wars may be fought not with fleets of human-operated warships, but with autonomous AI-driven vessels, energy-based weapons, and orbital defense systems. The question remains, will these advancements prevent war through deterrence or escalate conflicts into new and unpredictable arenas? Only time will tell.